on page 134 when we're done. So this is going to be an application of a limit. So when you get into calculus, this is your first application of a limit, one of the reasons that we need a limit. And so in order to do that, we are going to talk about rate of change, okay? And so what is rate of change algebraically? What does that mean? What does it make you think of? Slope, okay? So your slope is your rate of change, right? And we know how to find slope, right? So here's two beautiful pictures that I drew. And so the slope of a line is a constant rate of change. That's why you can pick any 2 points on a line and find the slope. It'll be the same no matter what 2 points you picked, right? Because the rate of change is the same here as it is here, as it is here, and so forth and so on. The rate of change of like an exponential, it's not constant. The rate of change changes, right? Because it's increasing slowly, then it starts increasing really, really quickly. So the rate of change at this point is different than the rate of change at this point. So when we talk about rate of change, there's 3 rates of change that we look at. Constant rate of change, average rate of change, instantaneous rate of change. If we have a line, which is the only thing you've really ever found the slope of, all 3 of those things are the same, okay? But here, on something like this, there is no constant rate of change. But I could do an average rate of change between 2 points because I need 2 points to find the slope, right? Instantaneous rate of change will be the rate of change at a specific point, but that only gives me 1 point. Okay, and that's why we need the limit definition of the derivative to help us figure that out, okay? So we're doing this when the rate of change changes. And I know that sounds weird, but that's why I wanted you to look at these pictures and think about the fact that the rate of change is changing. All right, so back over here, we have this parabola, right? And I have this point, which is x comma f of x. And if I want the rate of change at that point, there's a couple of things I can do. Just to find a good old slope like we know how to find it, I can find the slope between these 2 points, and that would give me, let's make sure that we can see this. That would be the slope of this line right here, okay, which is close to the slope of the other line that I really want, but it's not the same, right? This line intersects that parabola twice. Okay, and you learned these words in geometry when we talked about circles, okay? So if it intersects 2 points, this is called a secant line. So a secant line intersects at 2 points, right? What I really want is the slope of this line, because I want the slope of this function at this specific point right there. I sort of missed the point there, but you see what I'm saying, right? The problem is, again, I only have 1 point. I need 2 points to actually find the slope of something. Does that make sense to you? This here is called, since it intersects at 1 point, I missed a little bit, this is called a tangent line. Now, you're taught, because you were taught these things with circles in geometry, it can lead to a little misconceptions of things. So the definition of the tangent line that you learn in geometry is a tangent line intersects a circle at exactly 1 point. A secant line intersects a circle at exactly 2 points. So that leads to some confusion sometimes if that's the only definition you've ever heard when you get to the calculus part of it, because let's say that I have a function that looks like this, okay, something like that. And I want the line that is tangent to the function here at this point, right? So if I draw in my tangent line at that point, it actually intersects that function twice, right? It intersects it here and here. But this is still a tangent line, because in calculus, we don't always look at the entire graph. We look at a lot of pieces of the graph, and we have some restricted domains. So we talk about what's happening in the neighborhood of the point, or the points right around it. So right around in this neighborhood of this point, it only intersects at one point. Plus, this is not a great definition of a tangent line. It just touches the curve. But I think it kind of lends itself to make you understand that even if it poked through it, that would not be okay. It has to just touch it. It's on the outside of it. It hits at 1 point. If it can intersect it at an infinite amount of points, depending on, what the function looks like, I guess. I mean, it could be a lot of them. But if we're just concerned with some restricted domain, like from here to here, then it's only intersecting it at one point. Does that make sense to you? So I just want you to, didn't realize that those were confusions until, a few years ago when Ackerman and I were having conversations about that stuff. Because people would get to calculus and be really confused about why you could intersect twice. And it's, again, because in geometry, you're only talking circles, and it can't intersect twice because it's a circle. Okay, anyway, so back to this. So we've got our tangent line, which is what we want. The slope of the tangent line gives me the instantaneous rate of change at that point. But, again, the way we know how to find slope, it takes us 2 points. So if we want to find the slope of the secant line, we can totally do that because we have these 2 points here. But if I want my pink line to become more like my purple line, if we look at what these points are, this is x, this is an x value, and then this is x plus h. So h is just some value we've added to x to be able to get another point over here. So this could be like 3 and 5 because we added 2, whatever. If I want to get this point here closer and closer and closer to that point, then that means I need my h to get smaller, right? And so I need my h to get smaller and smaller and smaller. What's the only way that my two lines would be exactly the same? What would h have to be? 0, right? But then if h is 0, then they're literally the same point, and then I'm back to just 1 point, right? That's why we need the limit as h approaches 0. That's why we're going to evaluate that, okay? Does that part kind of make sense? All right, so now we're going to use these 2 points to actually find the slope. We're going to do that over here. So I know that slope is equal to delta y over delta x, which is also y2 minus y1 over x2 minus x1. We are big boys and girls now. You will never see that on another formula chart. You better just know how to find the slope of a line. All right, so then if I'm going to find the slope of my pink line over there, so my y2 is going to be f of, y2 is going to be f of x plus h minus y1, which is f of x, over x2, which is x plus h, minus x1, which is x. Okay, so you understand how I got that from my picture, yes? All right, and we have x, so x and f of x, that means x and y, right? That's why we're looking at it that way. Now, the denominator I can clean up a little bit. I don't get to cancel these x's out. That doesn't make any sense. But here, I can cancel that out. It just leaves me with h. So basically, I ended up with this, which is called the difference quotient. Difference, because we're subtracting, and quotient, because it's division. Okay. Now, that's the slope of the pink line. But remember, I want h to get smaller and smaller and smaller, so I need the limit of this as h approaches 0, like it says right here. Okay? So to approximate the slope m of a tangent function, we use the nearby point to create a secant line, then evaluate the limit. So basically, the difference quotient is the slope of the secant line, then we evaluate the limit to slide that point closer so that we actually get the purple line. Okay? We good with that? Okay, good deal. So let's look at how this works. It says to find the slope of the line tangent to the function at the given point. So here's my given point. This is my x. This is my y, right? This is also my x, comma, f of x. Another way to think about it. So we're finding the slope. The slope is equal to the limit as h approaches 0. Be ready to rewrite that 1,000 times, and you cannot drop it until you're allowed to drop it. So in the numerator, it's f of x plus h. Well, x is negative 3. So this is f of negative 3 plus h minus f of x, which is negative 3, all over h. Everybody with me so far? Just basically rewrote the difference quotient, but I put a negative 3 in there instead of an x. That's all I did. Okay, so now I'm going to actually replace my f of negative 3 plus h and so forth. So I'm rewriting the limit as h approaches 0. All right, so the way that I evaluate f of negative 3 plus h is I take this negative 3 plus h and I substitute it into the original everywhere I see an x, right? That's how we evaluate something. So x squared becomes negative 3 plus h squared. Then plus x, which is negative 3 plus h, and then the plus 1. Okay, so that is f of negative 3 plus h. Does everybody understand where everything came from? I just substituted the negative 3 because this is like, instead of f of x, I want f of negative 3 plus h, and I substituted it in there. Minus, and then f of negative 3. What is f of negative 3? 7. Because they gave me the ordered pair. This is x, this is y. This is x, this is f of x. So this is negative 3 and f of negative 3. It's another way to look at it. Okay? If they didn't give it to me, then I would substitute negative 3 back into the original, just like I did the negative 3 plus h, and evaluate it that way. Okay? And then all over h. All right, so then again, I have equals the limit as h approaches 0. And I have to simplify all this because if I just substitute in 0 right now, I have 0 in the denominator, right? That's a bad thing. So in the numerator, I need to square all that out. And when I square that negative 3 plus h, I do not just square the negative 3 and square the h because algebra. I square that binomial and I get 9 minus 6h plus h squared. Okay, so that was squaring this right here. Then I have to do plus negative 3, so I'll just do minus 3 plus h. Right, so I squared that and then put this in there. And then this is one positive 1 and a negative 7, so I can just do minus 6 all over h. Any questions about where anything came from? All right, so now I'm going to clean up the numerator. So this is equal to the limit as h approaches 0 of, all right, so this, I have a positive 9, a negative 3, negative 6, so those all just zero out, right? Then in the numerator, I'm left with h squared plus, oh no, then I have, that's a negative 6h, so I take care of my h squared, negative 6h plus h, so those together give me a negative 5h over h. That's why I cross them out as I use them, to make sure I've used everything and don't use something twice. What should I do next? Factor the numerator, good. So this is equal to the limit as h approaches 0 of, I've got h times h minus 5 all over h. Now I can cancel those h's out, right? That leaves me with the limit as h approaches 0 of h minus 5. Now that I've gotten rid of that h in the denominator, now I can evaluate, which means now I get to drop the limit statement. If I dropped it anywhere else, the whole thing's wrong and it doesn't make any sense at all. But the limit as h approaches 0, I'm going to evaluate by direct substitution, and I get negative 5. Now, what does that negative 5 represent? The slope. See this m we have here? It is the slope of the line tangent to that parabola at negative 3. Okay, that's your instantaneous rate of change. What questions do you have? Basic algebra in there. It's another one of those things that looks real bad. You better be able to keep up with your work, but the algebra in it is not terrible. Okay, any questions at all? All right, so let's look at number 2. All right, so I want so my slope is equal to the limit as h approaches 0 of f of 2 plus h, because they gave me the x value, minus f of 2 all over h. And this is something, again, you would learn at the beginning of calculus. You are likely to have a question that looks almost exactly like that, and and whether it's multiple choice or free response, but on the AP exam, and be able to understand it is the limit definition of what we're going to talk about. So it carries through. All right, so now I'm going to substitute. So the limit as h approaches 0 of, okay, so f of 2 plus h, I put 2 plus h in the original one everywhere, so c and x, so it's 1 over 2 plus h minus f of 2. What is f of 2? 1/2 all over h. Okay, before we get any farther, I wanted to do something at the beginning and I forgot. We know what this looks like, right? This is a graph that we talked about yesterday when we were talking about limits, right? Looks like this. Okay. So I'm looking for the slope of the line tangent to this function at x equals 2, which would be somewhere probably right about here or so. So we're looking kind of the slope of this tangent line somewhere right about there. Tell me something you know about that tangent line before we even do any more work. It's negative, okay? And is it very steep? No. And really, if you just, and you don't necessarily always have to know what they look like, but if you do, and you think about it, all of the, no matter what point I pick on here, so even if my guess wasn't right, all of those slopes will be negative, right? And it should be over here, so it's going to be negative and not that steep. So if I get like a positive 20, pretty sure I'm wrong, right? So this is not a way that I can guess it or anything like that, but at least kind of gives me an idea if you want to think about what's going on. Okay, so now that we have this here, I need to combine those two fractions in the numerator into one. So this is going to give me the limit as h approaches 0 of, all right, so in the numerator, my denominator will be 2 times 2 plus h, which means that first numerator becomes 2, and then minus that second numerator would have to be 2 plus h, and all of that is over h, okay? Because fractions. All right, so then this is equal to the limit as h approaches 0 of, all right, so 2 minus 2 zeros out, so that numerator, it becomes a negative h over 2 times 2 plus h, and h in the denominator. Everybody good? Don't make a rookie mistake on something like this because you didn't put parentheses and then you got the signs wrong. Okay, so now I have one fraction in the numerator, so this is where I want to do my whole keep, change, flip. I'm going to make the denominator into a fraction as well. You don't have to do that, but I think it's a very, very good idea so that you don't do something weird. Okay, you're much less likely to make a mistake if you actually have two fractions literally there. So this becomes the limit as h approaches 0 of the numerator, which is negative h over 2 times 2 plus h times 1 over h. So now these h's cancel out, and that's equal to the limit as h approaches 0 of negative 1 over 2 times 2 plus h. Now I can evaluate by direct substitution. So this gives me a negative 1 over what? 4. And does that make sense for what we discussed about our graph? Yeah, it's negative and it's not that steep, so I think that sounds good. And that's my slope. What questions do you have? Okay. We good? All right, so we have found the slope of the tangent line, but now what you're asked for often is the equation of the tangent line. And to find an equation of a line, you need a point and a slope. So this says if you know the slope of the tangent line at a given point, then you can write the equation of the tangent line using point-slope form. Slope-intercept form, y equals mx plus b, should have gone in the trash can a long time ago. You should only use that if you are actually given the y-intercept in some way, or you've already found it or whatever, and you have the slope. Otherwise, it's junk and you are wasting your time. Point-slope form makes it so much easier because you put the stuff in and then you stop and you're done. And you're not solving for y and doing it. You don't just, there it is, okay? That's the way to go. All right, so this says to find the equation of the tangent line. Well, in order to do that, we still have to find the slope. So we have to start off by finding what we've been doing. So we're going to find the slope. So the slope is equal to the limit as x, no, not as x, making up stuff, as h approaches 0 of f of 1 plus h minus f of 1 over h. We all good with that? Just doing the same thing we did on the front. So then this is equal to the limit as h approaches 0 of, so I take that 1 plus h and I substituted it into f of x. So this is going to be 2 times 1 plus h squared plus 1. And then minus f of 1. What is f of 1? 3. All over h. This is equal to the limit as h approaches 0. Okay, so I'm going to square that binomial and distribute the 2 at the same time. If it takes you more than one step, that's fine. But when I square that binomial, I'm going to get 1 plus 2h plus h squared. So that's going to give me 2 plus 4h plus 2h squared. And then I have my plus 1. And then I have my minus 3 all over h. We all agree with that? So now I'm going to clean that up. And this becomes the limit as h approaches 0 of, all right, so this 2 plus 1 is 3 minus 3 zeros out. And that leaves me with 2h squared plus 4h over h. Then what do we do? Factor out the h. This is equal to the limit as h approaches 0 of h times 2h plus 4 over h. The h's cancel out, and I have the limit as h approaches 0 of 2h plus 4. Now, I can evaluate by direct substitution, so that gives me 4. Now, what we're going to teach you when you get into calculus is that when it says find the slope of or find the equation of the tangent line, then actually the first thing that you would do would be that to write down point and slope, because you need those two things. And so you got to make sure that you actually find them, and you find them accurately and correctly. Don't make up math. So they gave me an x value of 1, so my point is 1 comma what? What's my y value? 3, right? Because we already found it. Right here. That's what your f of 1 is. So 3. And what is your slope? 4. That's the whole reason we did all that stuff, right? So now that we have that, we use point slope form, and we do y minus 3 equals 4 times x minus 1, and we stop. There's the equation of the tangent line. What questions do you have? Okay, so one more process with this. We are looking for the slope at any point. So slope at any point. So not just when x equals 1, not just when x equals 3, or whatever the other ones were. We're going to come up with an equation for the slope. So I have, this is my slope equation, meaning if I want my instantaneous rate of change when x is 2 or when x is 5, I can just substitute them into there. So it says we can also use the limit of the difference quotient to write an equation for the slope of the line. So what we're going to do is we're going to write an equation for the slope of the line tangent to the function at any point, and then use the equation to find the slope of the graph at x equals 4. So we're not going to start with 4 because I want an equation for any point. So any point means any x value. So instead of specifically using a number for x, we just use x. And it looks like this. The slope is equal to still the limit as h approaches 0 of, all right, so x squared, we're going to do f of x plus h minus f of x all over h. So we're using x instead of a number. And we do the same sort of thing. We substitute this in. So this is going to be the limit as h approaches 0 of, so I take that x plus h, I'm going to substitute it in everywhere in there I see an x. So this is x plus h squared minus 2 times x plus h minus 2. Then I have to do minus f of x, so minus, and I never leave myself enough room, x squared minus 2x minus 2. Yeah. I wrote way too big, sorry. All over h. Any questions about where anything came from? We good about where everything came from? All right. So then I get the limit as h approaches 0 of, all right, so when I square x plus h, I'm going to get x squared plus 2xh plus h squared. Then when I distribute this negative 2 here, I'm going to get negative 2x minus 2h. And then I have this minus 2 right there. Then I have to distribute the negative in here, so that will be minus x squared plus 2x plus 2 all over h. So then I want to clean that up, right? Okay, so let's look at what's happening. I got this x squared cancels out with that x squared. I got a negative 2x and a positive 2x. Those cancel out. I got a negative 2 and a positive 2. So the only things I have left are this term, and this term. See that? Because it's easy to get lost in your work. Cancel them out. So this leaves me with 2xh plus h squared minus 2h all over h. Any questions about where anything came from? All right, so what do I do in the numerator? Factor. Good. So the limit as h approaches 0 of, got h times 2x plus h minus 2 all over h. And those h's cancel out. So I get the limit as h approaches 0 of 2x plus h minus 2. Now can I evaluate? I can evaluate by direct substitution, so this leaves me with 2x minus 2, which is different than all my other answers where I just got a number, right? But remember, we were trying to find an equation for the slope. This is it. This is the equation for the slope at any point. So no matter what point I want the slope at, I can substitute that in. It's going to give me that. So this is part A. Then it asks me for the slope when what? X equals 4. So when x equals 4, the slope would equal what? 6. This is part B. And you can do it for any other x value. This right here, what we found, this is actually called the derivative. Okay? You're going to do derivatives all day long, all year long this year, okay? Now, when you learn derivatives, there are not shortcuts. Well, I guess there's shortcuts. There's definitely shortcuts to the limit definition of the derivative, but unlike yesterday, where I took you through all that division of x squared and then said, we can really just look at the asymptotes and know about top heavy, bottom heavy, tied in degree, and not worry about the rest of that. Yes, there's a different way to find the derivative of that, but the limit definition of a derivative, which is what this is still something that you need to know. Because again, you can see something that looks like this, And you have to be able to figure out what was f of x and what is the limit and all that kind of stuff. Okay, so this kind of doesn't go away. All right, any questions? Lots of algebra, but it's simple algebra. You can do it. You just got to keep up with your stuff. Make sure you can, read your own handwriting.